Okay, this is now section 4.4, and we're going to apply the techniques we've learned through 4.1, 4.2, 4.3 to solving story problems. The first type of story problems are the ones where you're translating an English sentence into algebra, and they'll basically have two sentences, and one sentence will be one equation, the other sentence will be another equation. So let's look at number 2 here. You're always going to start by kind of defining your variables. Here they're telling you what to do. Let x represent one number, let y be the other. Twice the first number decreased by a second number is negative 23. So twice a number decreased by a second number is negative 23. So you're just literally translating word for word from left to right. That's the first sentence, the second sentence in the paragraph. And then the third sentence, the first number increased by twice the second is 11. So the first number, increase means add, twice the second is just 2 times y, is equal to 11. And that's your system. Simply enough. That's the part, that's A. So they give you multiple choices to pick from. And once you get that, then you solve the system. So use whatever method you want. I think we can multiply the first one by 2. That'll make the y's go away. So we'll have 4x minus 2y is negative 46. And leave the second equation alone. Addition, the y's cancel. Negative 35, divide both sides by 5. Negative 7, back sub, so I have 2 times negative 7, so I'm just going with the first equation I saw. Minus y is negative 23. So negative 14 minus y is negative 23. Add the 14 over, so negative y is negative 9, and then multiply both sides by negative 1, so y is 9. So x will be negative 7. And then y is 9. Okay, so they'll drag you through that, and then they'll start with the story problems here. So the first thing you want to do is define your variables. Problem 3. Each day, the sum of the average time spent on grooming for 20 to 24-year-old women and men is 79 minutes. The difference between grooming times for 20 to 24-year-old women and men is 29 minutes. Given that 20 to 24-year-old women on average spend more time grooming than 20 to 24-year-old men, how many minutes per day do 20 to 24-year-old women and men spend each on grooming? So first, the unknowns from that last sentence. You're going to say, all right, let's let x equal the number of minutes women spend grooming, and then y be the number of minutes men spend grooming. And then you just go back to the sentences and kind of get your equations. So it says each day the sum of the average time spent on grooming for 20 to 24-year-old women and men is 79. So basically that just means the sum, x plus y, the number of minutes women spend plus the number of minutes men spend is 79 minutes. And then the second sentence says the difference between grooming times is 29 minutes. So the difference, x minus y, is 29. You want to be a little careful because you have to make sure that the one that's more is first. If men spent more time grooming, then x minus y would be a negative number, and we can't have that. That's why they tell you in that next sentence, given that women on average spend more time than men, then figure out the answer, right? So this is the appropriate setup. From here, we could just automatically do the addition method. X plus x is 2x. The y's cancel. Add here, carry the 1, 7, 8, 9, 10, so 108. Divide both sides by 2, and so x is 54. So the number of minutes women spend will be 54 minutes. And then to get the number of minutes men spend, you back sub into one of the equations. So I'll just put it into the first equation. 54 for x plus y is 79 minus the 54 And you get y equals 25 minutes for men. So each day it says women spend 54 minutes, and then men spend 25 minutes. Okay, this is the candy bar calorie type. So 1 bar of candy in A and 2 bars of candy B have 779 calories. 2 bars of candy A and 1 bar of candy B have 781 calories. Find the caloric content of each candy bar. So this is problem 4. We'll say X is the number of calories in bar A, and then Y be the number of calories in bar B. And then again, just use these sentences. 1 bar of candy A and 2 bars of candy B have 779 calories. So translating 1x plus 2y equals 779. And then it says 2 candy A bars plus 1 bar of candy B is 781. So you'd have 2x plus 1y equals 781. Here's your system. Let's do the addition method again. So I'll just multiply the second one by -2. And we'll have x plus 2y is 779. On the second equation, -4x minus 2y is 1562. You're going to make me pull out my calculator here. So this will be -3x equals -783. Divide both sides by -3, and x will be 261 calories in bar A. And then back sub, I'll just take that equation. So 261 plus 2y equals 779. Subtract the 261. So 2y equals 518. So y will be 518 divided by 2, which is 259. So they're both pretty much the same calorie-wise. You know, candy bar A is a little more you know what I mean, decadent. Not by much though, right? All right. This is the same kind of problem, except the x and the y don't represent the actual calories. Okay, so x and y in this problem represent the number of candy bars that you're picking up during Halloween. So it says a collection of Halloween candy contains a total of 8 peanut butter bars and chocolate bars with peanuts. So you went out on Halloween and you got 8 bars, right? A bunch of peanut butters and a bunch of chocolate with peanuts. Then it says the grams of fat in each of these candy bars exceeds the daily maximum desired fat intake of 60 grams by 65.2 grams. How many bars of each candy are contained in the Halloween collection? So we'll say X is the number of the peanut butter ones, and Y will be the number of chocolate with peanut. And we know that the sum of the peanut butter bars and the chocolate bars is equal to 8 overall. So there's 8 total. Then for the number of the grams of fat in total, you know, it's exceeding 60 grams, which is the maximum desirable intake, by 65.2 grams. So the number of calories that, or the number of grams of fat that you're getting from the peanut butter bars will be the number of peanut butter bars times the amount of fat in the peanut butter bar, right? So if you look at the graph chart they give you, so there's going to be this blue thing, and you click on that, and you just go to the peanut butter bar, which is the kind of greenish color. Well, wait, sorry, it's the bluish turquoise color, 13.7. So 13.7 times X will be the amount of fat from the peanut butter bar, and then plus the amount of fat you get from the chocolate with peanuts, right? The chocolate bar with peanuts is the red bar, and that's really bad for you. So there's 16.3 grams of fat per bar, right? And it's saying in total the amount of fat is exceeding 60 by 65.2. So the actual amount is not 60, it's 60 and then an additional 65.2. Okay. So that's our system right there. We want to maybe rewrite that second guy a little bit. So x plus y is 8. You get 13.7x plus 16.3y equals 125.2. You can multiply to get rid of the decimals if you want. So you can multiply this second equation by 10. So you get x plus y is 8. And then you get 137x plus 163y equals 1252. And then I'm going to multiply the first equation by negative 137. You could also do the substitution method. I'm just kind of stuck on this method, I guess. 37y equals, and then 8 times 137. 1096, negative 1096. And then we have 137x plus 163y equals 1252. The x's will cancel. 163 minus 137 is going to give me a 26y. And then 1252 minus 1096 is going to give me 156. Divide both sides by 26. And you're getting 6. So apparently you had 6 of the chocolate with peanut butter bars. And then I'll pick this equation. I'll do a substitute. So x plus 6 is 8. So you just have 2 of the peanut butter ones. Okay. So there's 2 peanut butter bars and 6 chocolate bars with peanuts. Great. Discount clothing store. All sweaters are sold at one fixed price, and the shirts are sold at another fixed price. If one sweater and 4 shirts cost $35, and then 4 sweaters and 5 shirts cost $74, find the price of one sweater and the price of one shirt. So automatically you say X is going to be the price of one sweater. So you just go to that last sentence usually, and that'll tell you what to make your variables. And then Y will make the price of one shirt. Okay. And then it's saying if one sweater and 4 shirts is $35, so one sweater X, 1X, plus 4 shirts, 4Y, is 35. And then it goes on to say 4 sweaters and 5 shirts cost 74. So 4 sweaters plus 5 shirts is 74. And then they want you to find the price of both. So again, you could do just multiply that first equation by minus 4. This would be minus 4x minus 16y is 35 times 4. It's 140, negative 140. And then 4x plus 5y is 74. So you get negative 11y is negative 66. And so y apparently is 6. So the price of the shirt is $6. And then you have x. Just go to your first equation there. apparently in eraser mode. Okay, there we go. All right, so I got x plus 4 times 6 is 35. So it'll be x plus 24 is 35. Subtract 24 from both sides. That will be 11 bucks. So the sweaters are going for 11 bucks, which is pretty incredible. And then the shirt is going for 6. Okay. This is kind of the sports problem. So we have the perimeter. All right, so there's some sort of badminton court or something like that. There's going to be a length and a width. We'll make the length x, the width y. And it's saying the perimeter of the sports court is 158 feet. So using our perimeter formula, 2x plus 2y is 158. Then it says, after the game, a player's coach estimates that the athlete has run a total of 396 feet, which is equivalent to 6 times the court's length plus 3 times its width. Okay, so that's another equation. 6 times the court's length is 6x plus 3 times the width, which is y, and that totaled 396 feet. Okay. So you have your system there. You can just go through and solve that one pretty easily. Let's move on to the next problem. A person is choosing between 2 cell phone plans. Data plan A has a monthly fee of 56 bucks and then a variable charge of $12 per gigabyte. So the price is going to be 12 per gigabyte. So I'll say, maybe we could call it 12G, and then plus this monthly down payment of 56 bucks. And then plan B, the price is a monthly fee of $48 down, and then plus $20 per gigabyte. Okay, so when will the plans be the same? How many gigabytes of data can I use for the plans to be the same? So that just means to solve this equation. So I'll do the substitution method. So first, the first equation is already solved. Well, both equations are already solved for P. So I'll just pick either one, and then you plug that into the unused equation. So secondly, I'll have 20, so plugging in 12G plus 56, and for P, I'll have 12G plus 56, and then that equals the 20G plus 48. Get all the G's on one side, all the variables on one side. Then move the constants to the other side. That looks like 1 gigabyte. 1 gigabyte for 1 gigabyte of data. Then you could back sub into the first equation. The price will be 12 times 1 plus 56, which will be 12 plus 56, which will be $68. That is ridiculous. If he uses 6 gigabytes data per month, which is the better deal and why? So this part B is just you plugging and chugging into the formulas for plan A and plan B. So part B, the price for plan A will be 12 times 6 plus 56. That should be 12 times 6 plus 56 on my calculator. I get 128 bucks. And then for plan B, that will be 20 times 6 plus 48. So 20 times 6 plus 48 is 168 bucks. So plan A is a better deal by 40 bucks. So you can use math to determine which cell phone plan you should go with. Question 9, the community center is selling a total of 299 tickets for a basketball game. An adult ticket is $4. A student ticket costs $1. The sponsor collects $581 in ticket sales. Find the number of each types of tickets sold. So we'll say X is the adult number of adult tickets. And Y will be the number of student tickets. And so it says the community center sells a total of 299 tickets. So the number of adult plus the number of student tickets must be 299. An adult ticket costs $4. And so the amount made from the adult tickets would be 4 times X, 4 times the number of tickets. And then the student ticket costs $1, so the amount of money made from the student tickets will be 1 times the number of student tickets, which is Y. And the total amount that they made was $581 in sales. So $4 for every adult ticket plus $1 for every student ticket summed up to $581. Okay, so there's our system. And this looks like a addition method type problem we want to do. So multiply the first equation by -1. You get negative x minus y is negative 299. The second equation, just clean it up a little bit, 4x plus y is 581. 4x minus x is 3 x's, the y's cancel. And on the other end, looks like 581, clear, 581 minus 299 is going to be 282-ish. And then divide by 3 is 94. So that it looks like they sold 94 adult tickets. And then going back to this first equation, 94 plus y is 299. So y will equal 205. So 205 student tickets. Okay, so 94 adults and 205 students. And looks good. Okay. Here's the investment problem. So basically, there is a kind of a formula that goes along with it. The interest is equal to the amount invested, which is usually called P for principal, times the rate. Okay? And the rate is used as a decimal. So for instance, if you deposited $100 into an account that made 10% interest, then the amount of interest you would get over a year would be $10. Okay, okay, so that we got to use that idea in conjunction with the information given. So here it says you invested $5,000 between 2 accounts, paying in 5% and 8% annual interest. If the total interest earned for the year is $280, how much was invested at each rate? So we'll say X is the amount invested at 5%, and let Y be the amount invested at 8%. And it first says you invested $5,000 between the 2 accounts, right? So in other words, the sum X plus Y is going to be $5,000. And then it says the total interest earned was $280. So the interest from account, the 5% account, how much interest is that? So that would be the rate times the principal, or the principal times the rate. Let's write it the other way around though. The rate would be 0.05 and then times the amount in the account. So this is the interest from the 5% account. Okay, and then plus your interest from the 8% account, which will be 0.08 times y. If you add those together, that's the total interest. Okay, this will be the total interest. And of course, that will equal $280. That's what the story problem says. Okay, and there is your system of equations. You can multiply the second guy by 100 if you want in order to clear out those ugly decimals. So I'll have x plus y is 5 grand, and then I have 5x plus 8y equals 28000. And then I think we can multiply the first equation by -5. And I have -5x minus 5y equals -25,000. And then 5x plus 8y equals 28,000. And then the x's cancel. 8y minus 5y is 3y's. That'll equal 3,000. And then divide by y. So it looks like you must have deposited 1,000 at 8%. And then borrow this equation. X plus 1,000 equals 5,000. So you deposited apparently 4,000 at the other rate, 5%. Okay, so it looks like 4 grand at 5%, and then you did 1 grand at 8%. Okay. The last two problems are these distance times rate problems. So if the interest problem had this formula, these problems are going to be d equals r times t, rate times time. Distance equals rate times time. On top of that, there's this idea that if you're going 30 miles per hour and then there's a wind blowing behind you at 2 miles per hour, your overall rate is going to be the 10 miles per hour plus the 2 miles per hour. So you'd be going like 12 miles per hour or whatever numbers I said. So for instance, if I'm going, let's say I'm walking at 3 miles per hour, and then there's wind blowing on me at, let's say, 2 miles per hour. The overall effect is that I will be walking at 5, and it's not realistic, but that's the idea, okay? So the rate of me walking will be the rate of the wind plus the rate of my walking. Okay, so we kind of use that idea in conjunction with the d equals rt formula to get our system of equations. So let's see what we got. Matt and Anna Killian are frequent flyers on Fast and Go airlines. They often fly between two cities that are a distance of 800 miles apart. On one particular trip, they flew into the wind, and the trip took 2.5 hours. The return trip was with the wind behind them, and it only took 2 hours. Find the speed of the wind and the speed of the plane in still air. So first we're going to define our variables. X, let's say, is the speed of the plane without any air blowing on it. That's why they say the speed of the plane in still air. That's what that means, no wind. And then let's let y equal the speed of the wind. So on the particular trip, they first flew into the wind. So when you're flying into the wind, so we're going to develop a rate and a time and set that equal to distance. So the rate into the wind is going to be the speed of the plane minus the speed of the wind, okay? And then they said that took 2.5 hours, and the overall distance was 800 miles. Okay, so that's our first equation. The second equation says the return trip, the wind blew behind them. Okay, so in that case, the rate is the rate of the plane plus the rate of the wind. And in that case, it only took 2 hours. So the time was 2, and it was the same distance, in other words, 800 miles. Okay, we can first divide both sides. So here's our system, but we can divide both sides by, in the first equation, 2.5, if you wish. If you don't want to, you can distribute and all that jazz, but I found it's easier to just divide both sides by 2.5. Okay. So in that case, you'll have the x minus y equals 800 by 2.5, which is 320. And on the second equation, if you divide both sides by 2, on the left, the 2's will cancel. You'll have x plus y. And on the right, you'll have 400. So if you do it that way, look, you'll automatically have a cancellation between the y variables. So you'll have x plus x is 2x's, y and the y cancel, and then you have 720. Then divide by 2, and you get x equals, it looks like 460 maybe. Okay. Which seems reasonable for the speed of a plane. If you don't know how fast planes go, 460 is reasonable. I'm just making sure 760 divided by 2 is what I said it was. It's not. It's, oh, sorry, 720 divided by 2. I think it's still wrong, but this is why I check. It's 360, sorry. So x is 360 miles per hour. And then back sub, so I'm going to use this equation. So 360 minus y is 320. Move the 360, move the 360. So you get minus y is negative 40, and then multiply both sides by negative 1. So the speed of the wind is 40, which again is reasonable. If the speed of the wind was 1,000,000 miles per hour, you would question that. So always keep your senses in check. Does this make sense? And then this problem 12 is the same sort of spiel, except now we got a boat, and instead of wind, we have the current of the stream. So it says a boat's crew rowed 20 miles downstream with the current in 2 hours. The return trip upstream against the current covered the same distance, but it took 5 hours. Find the crew's rowing rate in still water and the rate of the current. So we'll say x is the rowing rate of the crew, and then y will be the rate of the current for the water. And again, we have r times t equals distance, or distance equals rate times time. It's the same thing. Anyways, the first deal, they're going downstream. That means they're going with the stream. So that will be x, the rowing rate, plus the water rate, times time. It took 2 hours, and the distance was 20 miles. And then when they returned, they went upstream, so that rate is x minus y. And then the time was 5 hours, and they did the same distance. So they went 20 miles again. Okay, there's your system. Again, I'm going to divide both sides first. It seems like the way to go. So over here, the 2's cancel. You have x plus y. On the right, you just have 10. Second equation, divide both sides by 5. So you have x minus y equals 4. And then, lo and behold, the y's cancel. And it looks like the rowing rate is 7 miles per hour. Then I'll just pick this equation. X is 7. So 7 plus y is 10. Move the 7 over. So the water rate is 3 miles per hour, which again seems kind of reasonable. If your rowing rate was 300 miles per hour, there may be an issue with your answer somehow. Anyways, that'll do it. There's only 20 questions here, so not a lot of work. But anyways, I hope that helps, and we will see you next time.